All right, guys, we're getting into my favorite topic. This is actually part of what my master's thesis was on. And today we're going to be talking about the basics of I. Now, you may not know what that is. You may have heard about it. Hint is complex numbers, but we're going to go into it. All right, so the complex number system is actually made up of a couple of things. So if you're in your notes, you can see what this is. Go ahead and write on it all over. So complex numbers, the complex numbers is broken up into two parts. It's like an apartment complex, not like complicated complex. Okay, so complex numbers are real numbers. Now, what real numbers look like is that. And imaginary numbers. Now, you will not hear me call them that for the rest of the time. I'm going to be calling them I numbers. Okay? So I equals the square root of -1. Now, you guys are all going to say, oh, but you can't take the square root of a negative number. You can. It's just under the system of the real numbers, the numbers we've been working with the whole time, they don't exist. But as soon as we expand our number system to complex numbers, they do. Just like how decimals don't exist when you're counting. You don't go 1, 1.1, 1.11. You don't. Okay? So real numbers are going to be split up into two parts. They are called rational, which is things like fractions, and irrational numbers. All right? So let's get some examples of these. So an example of a complex number would be like 3 plus 2i, or 4.1 minus 3.6i. Those are examples of complex numbers. Imaginary numbers are numbers like I, 2i, pi I square root 2. All of these are imaginary numbers. Now, real numbers, you guys know them. It's numbers like 1, 2, 7, 4.3333, forever, right? Rational numbers are any numbers that can be written like fractions, so like 4/3, or 2, or 7.1. Ending decimals, numbers written as fractions, whole numbers, okay? All of those work. You can also add negative numbers like -3/5 also works. Okay, irrational numbers are numbers like pi, or like the square root of 2. These are numbers that never end, never repeat. They're just forever going on decimals. Okay, you guys have seen all of these numbers before in a myriad of different circumstances, all right? Okay, so normally in class, I would need 5 volunteers to come stand on a number line that would be in the classroom. Because you're watching the video, I don't have that. So what we're going to do is I'm going to have my 5 stars, literally they're stars, on my number line. And I need 2 negative numbers, 2 positive numbers, and a number on 0, and someone on 0. They will be performing operations, and we're going to decide what those operations are. Okay? So if you're looking at your paper, this should make sense. If not, okay, we're starting here. So I picked the numbers -5, -2, 0, 2, and 4. All right, so those are our numbers, and I'm going to ask those numbers to add 4. So -2 added 4 and ended up at 2. 2 added 4 and ended up at 6. 0 added 4 and ended up at 4. 4 added 4 and ended up at 8. -5 added 4 and got up to -1. They all shifted right. So this is going to be a shift, or a translation. And this is all going to the right 4. Okay, cool. And you would write that underneath where it says add 4 on your paper? Yes. Okay, so we're going to reset. We're going to go back to the beginning. And now we're going to subtract. So what do you guys think is going to happen when we subtract? Some of you are going to have it right. Some of you, we'll see. All right, so we're subtracting 3. So everything seems to be shifting left 3. 4 went to 1, 2 went to -1, 0 went to -3, -2 went to -5, and -5 went to -8. So this is a shift, or you can think of it as a translation using words from last year. Left 3. Okay, cool. All right, so let's reset, go back to the beginning. Okay, let's try this. Let's multiply by 2. What do you think is going to happen? Well, let's see. So 0 went to itself, -2 went to -4, -5 went to -10, 2 went to 4, and 4 went to 8. So like the further away from 0 it is, it seems it travels further. So this is a stretch, or you can think of this as a dilation. by 2. Interesting. And notice that 0 stays on itself. 0 times 2 would just be 0. It's very boring. So everything's stretching away from 0. Kind of cool. All right. Okay, so reset. Now we're going to multiply by something different. We could divide, but really all we do is get a shrink instead of a stretch, and sometimes you end up with decimals, and I don't want to deal with that, so we're not going to do that. Instead, we're going to multiply by -1. So let's see what happens when we multiply by -1. All right, so -5 becomes 5. Oh, it passed through 0, kind of weird. All right, -2 goes to 2, and that also passed through 0, kind of weird. So like if these were people standing on a number line, they'd be running into each other all over the place, right? That's a mess. So this is just something weird's happening. It doesn't look very pretty. So let's try this again. But instead, we're going to make sure that this star always stays away from this star the same distance. Okay? And this star stays away from that star, stays the same distance. So let's see what happens. We're going to try again. So we reset. Now we're getting rid of the crisscrossing. So what's a way that you think we could do that? Where we keep the order of these the same, but we somehow get this -5 over to a +5. How can we do that? Some of you may have gotten it. What if we did this? We rotated. Okay, so then could I get the -2 to the 2 and stay, like, not crisscross over that one? Looks like we can. And that is, in fact, what we do. So we do this rotation. So then my -5 goes to 5, my -2 goes to 2, my 0 stays at 0. It's very boring. My 2 goes to -2, and my 4 goes to -4. So this is a rotation, right, of 180 degrees. Well, that's kind of cool. So multiplying by -1, we can think of it as a rotation. All right, so with that knowledge, I want you guys to try these. So if you add 3 twice, it's the same as adding what once. If you multiply by 3 twice, that's the same as multiplying by what once. Okay, go ahead and give that a try.